Assalamualaikum warahmatullahi wabarakatuh. This is a presentation on numerical methods group assignment. So here are our team members. Irfan is a leader, me, Humaira, this is Johan and Nakib. For this assignment, we have to identify authentic engineering problem with different numerical methods to solve the problem. So we find an authentic engineering problem and see for its energy balance, which is the final electricity consumptions data to see how electricity is used over time. Students can analyze and predict the change in electricity for a specific year. For the data, the year of 2015 is used as the function in agriculture sector. So therefore, the data can be analyzed in numerical method using the Lagrange interpolation and Newton's divided difference method. Next, this is the data taken from Suruhanjaya Tenaga Malaysia Energy Information Hub. It shows the real data in energy balance of the final electricity consumption from year 2010 until 2020. In this manual calculation, the first method used is Lagrange interpolation method. We find the approximate consumption of electricity on agriculture sector for 2015 by linear and quadratic approximation. So this method used to show either the approximation we did get a close answer to the real value from the data. For linear approximation, the first order, it passes through the two given points. And all we need is to sum of the formula given in this picture with 2 points of x, which is 2014 and 2016. Then we get 41.5 as the final answer. To know the absolute error, we take the exact value from the data, which is 41. Then we minus the value of the approximation we get just now, which is 41.5. So the difference is only 0.5. For quadratic approximation, the second order, it passes through the three given points. It's same with the first order. The difference is only it takes 3 points of x, which is 2013, 2014, and 2016. Then we get the approximation is 41, with the exact value is 41, and the approximation also 41, so the absolute error is 0.
Okay, Assalamualaikum. My name is Johan Bezakwan. My matrix number is CE210148. So I will continue the presentation about manual calculation of Newton divided difference method. Okay, so this is the table that we already calculate the value of Fi0 till Fi9 from year 2010 till 2020. Okay, so we need to find the data of 2015. Okay, so for the manual calculation, we need to do the first divided difference till 9 divided difference. Okay, so the first divided difference for F01, we use the formula given for Newton divided difference, which is F10 minus F00 divided by X1 minus X0. Okay. So 26 minus 24 divided by 2011 minus 2010. Okay. So we get the answer is 2. Okay. Same also for the F11 is equal to 30 minus 26 divided by 2012 minus 2011. Then we get the answer is 4. So till F91, we use the same formula that we refer the value from here. Okay, till we get the final answer for F91. Okay, after that, we need to do the second Newton divided difference. Okay, so the value of 4 and 2 we got from the first divided difference here. Okay, then divided by 2012 minus 2011. Okay, for the first divided difference, we need to divide by x1 minus x0. But for the second Newton divide difference, we need to use the divide by x2 minus x0. Okay. x2 minus x0 here. 2012 minus 2010. Okay. So we got all the answer for second Newton divided difference. Okay. So from the answer we get here, okay, we can calculate the value of Fi3. We use the same formula, but just here the difference. Okay, this one is x0 minus x0. Okay. Same also for the fourth Newton, which is this one is x4 minus x0. Okay, just that the different calculation for manual calculation. Okay, so same for 5th, 6th, 7th, 8 till 9. Let's use the same formula, but the difference is the x9 minus x0. Okay, so after we got the zero value, then we need to enter all the value that we get from the first till 9 Newton divided difference. Then we can enter the value into the formula here, okay, to find the data of F for 2015. Okay, so here we already show the value that we get into the formula, then we get the final answer for 41.976. Okay.
My name is Muhammad Irfan Menhot with matric number CE210186. Okay, today I will explain for my part, simulation part. We are using Maple for this project. So for the first method we are using for our assignment is Lagrange method. So there basically it has two part, linear Lagrange and also quadratic Lagrange. So for the first one, we need to declare x, which is what we have to choose, and also what we want to find in this assignment. So for the first one is x is equal to 2015. So then press enter. So we need to choose two variable. First one is x0 is 2014 and also x1 is 2016. Next, we put the f given in the assignment. So in the project, f0 is 36 and f1 is 47. And then we just calculate it using the formula for the Lagrange, linear Lagrange. So this is the answer. So next is the quadratic Lagrange. Also the same thing, but we need to choose three variable here: s0, s1, and also s2. And then also three variable for f0, f1, and f2. And then calculate for the quadratic Lagrange, and we get the answer is f is equal to 41. Okay, next I will explain about Newton method. So first is we need to declare it using the Newton method declaration. So first is we need to put SY, and then the years for electric consumption agriculture, and then the data given for the data from the data, and then for 2015 we didn't need to put it here because we need to find it, and then also the declaration here, and then the approach of the declaration, we will find or the data from the table will came out in this simulation. Next, we put the f0 34 for the initial, and f1 until the f9 here. And next is what we need to find it is 2015 for the first x, and then x0 to 2010 until 2020. Finally, we just calculate using the Newton method differential, and then this is all the calculation here, and then we get the answer is f is equal to 1763 over 42. So that's all for the Newton method. Thank you.
Before that, my name is Muhammad Akib bin Isnin and my metric number is DE210090. Okay, result and discussion. In general, when dealing with engineering problem involving missing point or data, Lagrange interpolation and Newton divided difference were the best method to solve this type of problem. Lagrange interpolation is process approximation, approximating a function and estimate the missing function value of over the interval. For Lagrange interpolation, which is quadratic interpolation and linear, this technique will be used to approximate the net consumption value for agriculture in 2015. In the result section, we will compare the manually calculated values with those obtained through software. Okay, the linear approximation method is Lagrange interpolation, which is the same result for manual calculation and maple simulation. By applying the linear approximation formula, we will get the value of the 2015 is 41.5 kilo to or K2. This value is consistent with the result obtained in the maple simulation. Newton divided difference is a numerical procedure for interpolating a polynomial given a set of points, which is the second method. By using this method, a polynomial of degree n is generated, and this Newton divide difference also identical result for net consumption of 2015 with manual calculation and maple simulation. In this approach, we can get the F01 and through F09 and calculated using the appropriate formula and then substitute into the equation. Okay, according to the manual calculation, the net consumption for the 2015 is found to be 41 kilo too, a result that is almost identical to value which is 41.9762 for function 2015 through the maple simulation. Finally, we can confirm that the value obtained is valid when comparing the calculated value with the actual data from the reference. As said earlier, the value will be different with the actual data because the value calculated is approximate value.
Okay, for the conclusion, for energy balance, the final electricity consumptions data is taken to see how electricity is used over time. The data taken shows the increasing electricity consumed by this sector that can be analyzed by numerical method using the Lagrange interpolation and Newton's divided difference method. On top of that, it concludes that Lagrange interpolation, linear approximation, which is first order, quadratic approximation, second order, and Newton divided difference are the most relevant method in to find the missing value of year 2015 export data. For Lagrange interpolation, both linear and quadratic interpolation techniques will be used to approximate the net consumption value for agriculture in year 2015. Okay. The linear approximation method in Lagrange interpolation yields the same result for both manual calculation and maple simulation. Newton's divided difference also yields identical result for the net consumption of agriculture in 2015 through both manual calculation and maple simulation. So according to the manual calculation, the net consumption for the year 2015 is found to be 41 keto, a result that is almost identical to the value which we get 41.9762 for the function of f 2015 obtained through the maple simulation. So that's all for our presentation of the project. Thank you.